When most people hear the word asteroid, they imagine a fiery space rock crashing into Earth in an epic world-ending explosion. Thanks, Hollywood. But in reality, asteroids are far more fascinating and far more important than just disaster movie villains. So what exactly is an asteroid? Asteroids are rocky remnants from the early formation of our solar system leftover building blocks that never quite formed into planets. Most of them orbit the Sun in a region called the asteroid belt, located between Mars and Jupiter. There are estimated to be over 1.1 million known asteroids in our solar system, and scientists believe that millions more are yet to be discovered. These objects vary wildly in size, from tiny rocks just a few meters across to massive beasts like Ceres, which is about 940 kilometers wide and technically classified as a dwarf planet. The asteroid belt itself is immense. It contains trillions of tons of rock, but contrary to how it's shown in films, it's mostly empty space. If you flew a spacecraft through the belt, you'd have a better chance of missing an asteroid than hitting one. Now, there are several types of asteroids, categorized based on their composition. C-type or carbonaceous asteroids are the most common and are rich in carbon. S-type asteroids are silicate-based and contain a lot of metal. M-type asteroids are mostly made of nickel and iron. Asteroids come in all shapes and spin at different speeds. Some rotate once every few days. Others, like asteroid 2014 RC, spin once every 15 seconds. And yes, some even have moons of their own. Asteroid 243 Ida, for example, has a small moon named Dactyl. But how close do these things really come to Earth? Enter the near-Earth objects, or NEOs. These are asteroids and comets with orbits that bring them within 1.3 astronomical units of the Sun, which means they can come relatively close to Earth. As of now, NASA tracks over 30,000 NEOs. One particularly famous NEO is Apophis, an asteroid about 370 meters wide that will come dangerously close to Earth in 2029, closer than some satellites. While it won't hit us, it's a wake-up call about the very real potential threat asteroids pose. Let's get into some impact history. The most famous asteroid impact happened 66 million years ago, when a 10-kilometer-wide asteroid slammed into Earth near present-day Mexico. The resulting crater, called Chicxulub, is over 110 miles wide and is believed to have caused the mass extinction that wiped out the dinosaurs. That impact released energy equivalent to 10 billion atomic bombs, caused global wildfires, plunged the planet into an impact winter, and triggered massive climate shifts. It's a reminder that yes, asteroids can change the world literally. But these events are incredibly rare. The odds of a dinosaur killer asteroid hitting Earth again in our lifetime are extremely low. According to NASA, an object that size hits Earth roughly once every 100 million years. Still, smaller asteroid impacts are much more common. In 2013, a 20-meter-wide asteroid exploded over Chelyabinsk, Russia, with the force of about 500 kilotons of TNT, roughly 30 times more powerful than the Hiroshima bomb. It shattered windows, injured over 1,500 people, and reminded the world that even modestly sized asteroids can be dangerous. To defend against these threats, NASA launched a mission in 2021 called DART, the Double Asteroid Redirect Test. The goal was to test if we could deliberately alter the path of an asteroid using a kinetic impactor. DART successfully slammed into the asteroid Dimorphos, a moonlet orbiting a larger asteroid called Didymos. The impact changed Dimorphos' orbit by over 30 minutes, proving that asteroid deflection is not just science fiction, it's a real and achievable planetary defense strategy. And more missions are in the works. In addition to defense, asteroids offer huge scientific and economic opportunities. Some contain high concentrations of platinum, gold, cobalt, and rare earth elements. Companies like Planetary Resources and Deep Space Industries have even proposed asteroid mining as a future industry. Beyond resources, asteroids carry primordial material unchanged since the birth of the solar system. Studying them can reveal secrets about how planets formed, how water came to Earth, and even the origin of life itself. NASA's OSIRIS-REx mission returned samples from asteroid Bennu, a carbon-rich NEO about 500 meters wide. The samples will help scientists study the asteroid's chemical composition and age. Bennu itself has a 1 in 1,750 chance of hitting Earth, though not for another 150 years. Japan's Hayabusa 2 mission also returned samples from asteroid Ryugu, another carbon-rich object. These missions show how nations around the world are taking asteroid science seriously, not just for safety, but for discovery. So, should we be afraid of asteroids? Not exactly. But we should respect them. They're not just rocks in space. They're time capsules, threats, and resources all rolled into one. And while Hollywood likes to show us nuclear bombs and astronauts drilling into asteroids, the real science is just as dramatic and far more hopeful. We now have the ability to detect, track, and even deflect incoming space rocks. And as our technology improves, our ability to manage these cosmic threats and opportunities will only grow. In the end, asteroids are more than just potential doomsday objects. They are a key to understanding the past, protecting the present, and possibly even fueling the future. So the next time you hear the word asteroid, don't just think of the end of the world. Think of the beginning of one.